Hello, everyone, and welcome to the broadcast. We are starting extra early today. I've wanted to start early anyway, but I have been granted the gift of rest and sleep, so we're going to make use of that and try to win back some ground that we lost this last week. Let's check in with the cats real quick first. We do have, let's see, four. There was a fifth one briefly. But we have four of them visible. We have Sky, Ember, Sammy, and Mason. Most of them nap ready, though Ember is getting a little bit of bath going on there. It'll be a Sprite Art Day in just a moment. Ta-da! Okay, so a big thing that I want to accomplish today is start to shift over to 32 by 32. For those that have been following previously, we've been using 16 by 16, which is this much. This is the 16 by 16 sprite blown up. So you can see. Turn that off. Blown it up 4x, so we're adjusting it. I do want to try to get over to this little guy. This is going to be a bit of a process because you can see there's a great deal of additional detail. While I am remembering it, to do that. No glow on the plug. Yeah, so you get to see more of what the catbot actually looks like this way. You definitely get the shape in the prior version. A couple of things that this is going to grant us is one, additional detail. So we can get things like, you can actually see that there is a door there, that there is the little readout in that case, in the old catbot model instead of the window into the nano core, the heart there. It would just be a little power meter readout. Very Mega Man health bar turned on its side. I haven't decided whether we'll have the mouth visible or not. We're still going with a manual outline, this dark purple color. It may not be apparent, but this outline is a different color. Might not be visible to you. For those on Twitch, it does say coding, but I feel like this counts. It's part of the game dev process. If you ever think, hey, I'm going to become a programmer and you're never going to touch art, UI, documentation, PowerPoint, I have bad news. All right, so we have a couple of animations. There's also some animations I want to get into. We haven't done this one in-game yet. Back in the Noida days, there was an animation for this, and what would happen is there were a couple of them, but this is the jumping animation. So we have, knees bent, lowers down, leaps up, coming back down, landing, brace. So different chunks of this were different parts of the Noida animation, with a variation of this one being in a loop. I don't know if we'll ever use the old attacking animation. I thought this was fun. Nice little, we get the little Mega Buster arm unfolding, similar with it being a kind of brace, crouch, and the fire animation kicks them up an extra pixel, and then they brace and start to retract the weapon. Because the default animation of the 16 by 16 catbot always has an arm forward, this smoothly transitions in and out of idle and running. neat stuff. There's your backstory and additional procrastination for getting on with it. Let's get another couple layers put in here. You can use a sprite to have an actual animation sheet where you would have 4 of these, and you could have it be that it auto feeds through them. You could have animation frames. And then you could export it as a sprite sheet. I am sure there's a way to make it work better for that. But I've had nothing but problems getting it to work that way. And it also prevents you from as cleanly using the layering mechanism here. So we are going to temporarily, at least, add this blinding red color. And we are just gonna paint the whole thing there. We won't use it constantly, but it'll be a good thing to catch if I'm missing any alpha in there. If I've got any transparent spots that I've left. Okay, so for the first animation, we need to get... we need to make sure... that we are properly lined up. If you look, we were 1 too high. Since we blew this up in effectively double in each dimensions, it's 4 times bigger, we ended up with the less need to have it visible real estate. There is less outline. Like, less of the percentage of the whole sprite is outline. All right, so this is entirely just legs go down, and generally the tail will hit the floor there. So it will be much like this one. Let's do another one. I have eaten one of the sprites already, that's fine. What I wanted to do. Into this one, we select that, we go here, we paste into it, hide that. Okay, we have the new one. So in new, we're going to paste over here and put you here. Hide the old one. We need to bring him down one little bit here. And that should be pretty reasonable. We're just going to sample that. Just going to sample that color. Switch to brush. Do that. You out. Down slightly. All right, so then arms out. This is our idle animation, bit bounce and squish kind of thing. Not a big difference with it, but there is the so standing fully upright, you have the 2 size leg, and you can see it goes down a little bit, arms out, arms back in, arms fully in, stand back up. With a little bit of twitch on the tail when we're at the kind of the bottom of the arc there. We generally don't get a hold still animation, but if you do, it'll be that kind of little bob in place. So that's down a little bit. Then we're going to raise the arms a little bit. We can't we could definitely not see it in the 16 by 16, but you can see a little bit more of the detail in that one, legs and arms are about the same length. Canonically, I think the arms are a little bit longer. There's a real kind of Robbie the Robot vibe with the original design of the Catbot. But with the legs and a little bit with the arms, you can see the sort of almost telescoping pattern for the more modern take, the kind of bendy limbs of Bender from Futurama would be a way to look at it. All right, so let's see here. Not sure how I want to do that. Don't even know if we need... down. Okay, no, it's down and then arms out fully. Let's just roll with that. Well, hello there, White Wolf. Good to see you again. It has been a bit. Hoping that by widening the window of viewership that more people will be able to watch anyway. So with luck, some folks that haven't been able to watch will be able to if I can get my act together. Pretty good, White Wolf, pretty good. We have a lot of the weapon functionality in place, a lot of the power-up kind of stuff in place, but one of the things that I've been running into as far as... one of the things that we have run aground on is presentation of the UI, because 16 by 16 was greatly limiting some of the stuff that I could do with like icons. So pulling the trigger and working on the 32 by 32 of the player. Take this up. Know if this is actually the way that I want to do this, but technically it should be one longer than that, give or take. Not quite, you know. Let's try it with both arms here and get... just get a look at it and see how we feel once it's in place. So again, kneels down a little bit. You can see the last segment on the legs kind of collapses in, arms out, so we're kind of at full crouch here. Then we are going to revert. This is this one again. It's a repeated frame. Now it is arms in. We pull the arms in. Tail goes down in the arms down again. That's right. Okay, now we do this one, but arms fully in. I get that, White Wolf. I get that. Things can get odd sometimes. Pretty much. Life being life, you know? That's a good way to put it. I think we're just going to go with this. We're just going to pull the mitten in. Like that. Then re-extend legs. Take that, raise it up a little bit. You can do this. I use Krita for things like thumbnails, and I've done it for some of the drawing streams. You can use that here. I find that Krita is a little harder to work with for fine sprite work, for like tiny sprite work. I have seen people use it for larger, like higher res sprite work. Since we're higher up, we can get down. Be a lot of movement for the pom-pom there. We'll leave it that way. The tail will go. We'll have plenty of movement there. Okay, so we should have that slight bounce there. It's much more subtle. It'll mostly be the hand motion, and I don't know that that's going to be great, but there will still be a very slight bob, and that's what we want. Might add some additional, like have the ears bounce down a little bit, starting here. So if we take that. Yeah, that doesn't look right. We still need to maintain the point a little bit. So it needs to look like it bobs down. So if I take that forward, like that, and then I think that's one of the fun things with sprite art is that you have to aim to do more with less. I might need to squish him further in this frame. I think we're going to do that. That, pull you in like that, which means the tail needs to go up one more notch here. Yeah. There's more squish here. That implies to me in theory this is backwards, actually. The ears should be squished coming back up. Okay, but let's get the rest of it in here. I want him to be at... We are going to take you here. You over here. We want to exaggerate the motion more. We have more room for, like, the... We have more room for the rubbery motion. So we are actually going to take him and move him up a little bit. That. We go up one more pixel here. So what we're going to do is the ears will lengthen a little bit until we hit the bottom so that we can exaggerate the squish here. And then pop back into place towards the top. So down 1, down 2, up 1, up 2. This is back into neutral as far as height. And then 1 further. So we get a 3-part cycle as far as the squish. This should create a noticeable bounce. Now this all happens in about a second or so. So this ear motion will be pretty heavy. So there's a bit of a blur here with the ears. So these are kind of the keyframes, down to here and then back up to here. See if we can get the tail motion to be a little heavier here then. Okay. Going to do the same thing with the ears here. So still a bit squashed. So stretch down into the squash, start standing up. We're kind of at neutral here, and we kick up a little further. I kind of want the stretch ear to go all the way down to the bottom of it. So ears stretch down into the full crouch, then as they're standing back up, we get a little bit of a squash here. Let's actually put it back at neutral there. Down to neutral, flatten as it stands back up to neutral, stretch body a little bit. Okay. Looks like it might work. We might need to tune that, but we'll go from there. Walking is going to be trickier. I've run into that a lot too. Long projects are something that require persistence. It is. Like, there are some things that I need to get back to. I want to get some 3D printed stuff rolling, but I keep having mechanical problems with it, so I've only poked it a little bit. It's very fiddly. Okay, so walking is a 2-stage bounce here. So you can see up, up, down, down. With the first down being the left leg, this forward leg here. The second down being the right leg, the back leg. So you can see left leg forward, left leg coming down, left leg planted, so that's straight down, the kind of neutral down, with the right leg back a little bit. Then right leg comes forward, right leg coming down forward, right leg down and pushing backwards. So you get that kind of step and push, step and push. With the push motion, that final kickoff, always causing them to bounce into the air. This gives us kind of a hopping motion. We want to preserve that. Okay, so we're looking at up at least one. Don't want to bounce too much, so this is going to be I should probably start doing that again, and I can probably start doing that again a little easier or a little more frequently. I'll have to wrangle it, but that is a good point. I should be doing that again. circumstances have changed, and a variety of circumstances have been all over the place. So I think we can swoop back into streaming on tall format. All right, let's check. We do tail motion. Still kind of neutral. Tail motion was kind of neutral. Yeah. We'll keep it at that stage and just have it bob up and down here. This is up one, down one. Just going to put line. And then this should be right leg down. This should be, well, left leg. This should be right leg down. All right, let's look again. We need... So left leg should be kicked a little forward. Right leg bottom should be kicked a little back. So knee should be coming forward here. Whereas it's more the ankle going back here. I don't know that I like that. I think that'll work. Then the entire leg forward and planted. That. This, the entire leg is back and extended again. Here, brush there, like that. Okay, and this part just is back. Leg planted and neutral. Okay. Now, right leg is coming forward, left leg going back a little bit as we step. that bounce now. Left leg is starting to fall behind. So we're generally doing one general pixel of motion here. Left leg planted, right leg coming back forward. We'll see how that plays out. This is all of the animation we need, though, to make this part of it work. Okay, so now we're going to go into our definition of player Nyanite here. We're going to copy that over, and we're going to say _32 for the time being. With this one being 32, 32, _32. Okay. Get our Visual Studio rolling here. Did we break it? Oh, I like the bounce and stretch on that. I like that a lot. Look at him go. Then the walk looks decent. Might put some more arm motion in the walk now. Right now the arms aren't moving. We'll leave that for now. That's... For one, color is going to be a little bit tricky there. I'm going to need to decide how I want to handle overlap. But for the most part, it's when left leg is, or right leg is most forward, left arm will be most back. I'm sorry. Right leg is most forward, left arm will be most forward, and vice versa. So here, this arm needs to be forward. Whereas here, this is the second plant. This leg has been fully planted. Sorry. This leg is planted. The left leg is planted. Right arm should be forward. Right leg is planted. Left arm should be forward. But because we aren't dealing with 2 pixels, we have a little bit more play we can do here. For the time being, we'll leave it as is. Okay, we've got that one. Now I need to look at how we set this up, which is going to be in our renderer here. It's a mesh renderer. So each quad mesh we do with the mesh. Like setting a property by string. I'm looking at is, can I change the mesh size? Is mesh. Is the multi-mesh. Remembering we don't actually need these anymore. We'll leave it for just a moment. But these are globally available now. And I do want to come up with a better way to do this loop. But one thing at a time. Okay, so there is a predefined quad mesh that we use for everything, and that will define the overall size. But how to deal with this? Because not everything is a 16 by 16. That's why the 32 by 32 sprite was the same size as the 16 by 16s. Because the screen dimensions it was using was 16 by 16. It just mushed it. Which works fine because we have a scaling factor of 6. So there's way more pixels per pixel. Per actual pixel. So let's temporarily look at this. Oh, definitely not that. So we're gonna tamper a little bit here. Everything should be too big here. Yeah. Because again, we've stretched them all out. see. Scaling multipliers for left, right, flip. The frame size is what we're interested in, but frame size gets tricky. So we're considering frame size. And the frame size compared to the maximum frame size that we've encountered is what we're interested in. Because we need to superimpose it within a 32 by 32. We don't want to bloat it out either. It needs to fit within it. At least it needs to be centered inside of it. Some of this can be handled in the shader, but that would mean that we also need to still communicate the maximum boundary for it. That is, if we say that the maximum size of a mesh square is 64 by 64. We can programmatically determine that here. We then need to communicate that into the shader so that it handles the frame size proportionally. This is percentage of the frame size. Again, there is an assumption of X and Y on a frame are identical. This is another that we could mess with that. Okay, if we say 64 by 64, we're going to give ourselves a very large area to render in. This is percentage of the texture that we're going to use. Let's pull up the shader as well. Still haven't updated to Godot 4.4 yet. Update available. I don't need to, but I want to. I wouldn't mind testing the Godot intrinsic physics and whatnot as an alternative. Rendering is an expense, but it's not the biggest expense to this process. So we're determining which frame that we've got. Need to change this going forward as well. But anyway. All right, let's translate out. So For each portion, we're figuring out which texture it is and which part of that texture to use. We have a hard assumption that all animations are 6 frames long. We can change that in the future, but we're going to need to figure out how to do it. This might be another property that we pass into the shader. Which is another reason I wouldn't mind being able to switch over to Godot intrinsic rendering. The strength of the system we're using is that it offloads most of the work to the GPU, and it is using a entity type that happens all at once. The weakness of it is that I have to do everything very roundabout in the shader. I could have stuff in the shader still in this other method, but because it is one big rendering pass, I can't have things like particle effects interleaved with objects. I don't know if that's a bad thing, but we'll see. Hello, Endless. Welcome. We're looking at adjusting a shader so I can get the sprite a sprite resized accordingly. So let's see, this is the fraction of the frame I'm using. This is the coordinate that it wants to render at. Fraction of the frame. Which frame we're using. So again, we're using 1/6 of the thing. But we need to deal with an offset, because right now it's UVX is based on us rendering to the entirety of it. So one of the core assumptions here is that the frame size is the entirety of the mesh that we're rendering to, the entirety of the rectangle. For those that are new to the channel, so I don't cover the camera. Those that are new to the channel, we are working on a game. Vampire Survivor style game with modular weaponry. And we're updating the visuals to be 32 by 32. And we're working on resizing all of this stuff to work correctly. So if we know what the UV should be, so the UV is in the entirety of it. So we should know that there's a fraction of it. We're going to force the fraction. So if we know it's a 16 by 16 inside a 32 by 32, we only want that inner portion of it, that sort of inner half. But how to calculate that? Because it can't just be we need an offset. We need to set up an offset. Yeah. What we're trying to do is, since we can't change the size of the mesh as we're working with it, we need to change the size, how it renders to it. Let's put this back how it was inside of this code. We're going to put you back to 16 by 16. We're going to want it to be 32 by 32 for the time being, but right now you can see this is a 32 by 32 sprite rendered in a 16 by 16 square. So it looks small. This isn't terrible as far as visually, but I want to be able to make it so that the yarn balls and the blobs are smaller than the player. I would like to have things be reasonably smaller, and being able to scale them up and down, or to be able to show that size differential is important. So we want to be able to do 32 by 32. But doing that, the 16 by 16 scale up accordingly. They are the same size because of this. Is there a way when I'm setting the instance to change that? Because if I can change that in the instance, we're set. The scaling could be a thing that we use for that. So if we say 16 by 16 is the smallest possible, sorry, no, we're going to say 32. We're going to hard code that for now. But we could programmatically determine it here by saying, what is the ratio? What is the frame size ratio? Which isn't perfect. We still need to work through that. This isn't quite right. When it's smaller, we need to shift it into the middle. We need to scale it down when it's smaller. So if we start with 6, this is float scaling multiplier, and yeah, it's equal to 6. So scaling multiplier is equal to, so it's times equal. No worries, Endless. We've been at this for a bit. I do most of the work on this on stream so that everybody can see what I'm doing. Before this began, I had never touched Godot. And professionally, I had not worked extensively in C#. We have learned to use Godot on the fly, and I have taken C# from into more familiar territory for me. So it's been a good times. It's been good times. Frankly, though, I'm familiar enough with code that learning C# was not difficult. first programming language I actually learned to use was C++. So shifting to C# after learning more about coding in general was pretty easy. A lot of the C++ style conventions are still preserved in C#, which I like. Okay, this is entity mesh texture wrapper dot frame height divided by 32. So then times scaling multiplier. Yes, do not feel like you're obligated to jump in and suggest how to do stuff. It is fine to lurk. It is fine to comment on other things, ask questions. Very casual. Okay, well, that's a problem. This is a problem. Scaling multiplier is 6. Scaling multiplier is now 32. Okay. Okay, let's get some of the other things spawning first. But they're not. Why are they not? What else did I break? Okay, well that works properly. So if we don't change it, part of the problem happens here. This is we don't scale them up as much if they are... So we should already have them here, is the thing. So this is a 16. So I step over this. Scaling multiplier becomes 0. Because this is integer math. That's why. Problem located. Okay. This is an integer. This is an integer. And thus, this is 0. Float. Ta-da! I feel like... No, I think the walking motion is fine. I do want the arms to move a little bit more. And maybe I can exaggerate the walk a little bit more, but that should be fine. I do like the little idle bounce that he does. I like that a lot. But we can also do this here. We're not going to do this ultimately. We are going to make the frame size appropriate. Yeah, core gimmick of the game is going to be the way that we set up the weaponry. So, yeah, for those of you that are new here, homing mouse splits into 3, it moves in a spiral, and let's see, where is the on impact? On impact, use the next weapon. We will split into 3 inward spiraling yarn balls. I'm sorry. 3 inward spiraling yarn balls that pierce once. So weaponry is modular. Exactly when you're going to be allowed to edit the weapons is not yet determined. But the general pattern that we're seeing here is what you can expect to have. And that is you unlock new weapons and you unlock upgrades. The upgrades are loaded in from left to right off of the list on top of what this naturally does. The mouse naturally homes in. The yarn ball naturally aims at an enemy initially, but rolls in a straight line based on that initial direction. So you could sidestep it effectively. And the yarn ball bounces intrinsically. All of this other stuff is added left to right. If you have an ability like this one, notation on it is not yet fully determined, but the white line currently means it will take over the next weapon. So this notation means on impact, emit the next weapon. So the yarn ball no longer fires independently, it fires when the mouse hits something. The reason that you would do this is if the weapon that you've got could be more useful if it is set off where it's delivered, or if you already have a really good coverage with the first one, then the second one kind of piggybacks off of that coverage. So now the mice will emit yarn balls. This will make it get out of control quickly. But this is one of the reasons that you would use, you would consume the other weapon, is because now the mice are causing way more yarn balls than normal to enter existence. Would this be something that would exist in the game? Yes, but there would be a bigger cost to doing it. We are not yet at actual gameplay, though. We are at, there is technically a game in effect here. So one of the reasons that we're doing all of this shader stuff in Similar is to handle some of the performance that we need to be able to cover when we have a huge amount of stuff happening at once. Right now, it might be hard to tell, but it's mostly the yarn balls. It's mostly the little pink and blue things. But there's about 7,250 things active right now. And we're getting about 6 frames per second. If I call this back down to a still excessive number, it'll take a moment for them to die off. They live for about 10-ish seconds. With about 1,000 things on the screen at once, we've got 200 frames a second. We can still do better than a lot of this, but most of the cost of the game is in the things moving, like how they move around, and whether they run into other stuff or not. That's where most of the expenditure is going. So we can see the spirally ones will start dying off. But yeah, general theme here. We have map generation, at least how I want it for now. The red and blue squares are a demonstrator of the map generation. Haven't decided if ultimately we'll be doing something procedural, or what. You know, where you start will be fixed, but I'm kind of tempted to do full procedural, if for no other reason than it removes some of the repetitiveness of the maps. If instead of, we could expect a greater variation, I think would be a better way to put it. We could still have fixed things that say there is a known map chunk that exists. Like the starting map chunk looks like this. There is a map chunk at this coordinate that looks like this, so that you can still get those set piece objects like we see in other Bullet Heaven games of this nature. But we don't have to prescribe as many of the map chunks. We can say, here is your generation algorithm, run with it. I don't know how that's going to land. For the time being, this is how it works. There are 2 maps that you supply it with. The map that we're seeing right now is the red map. This is the core map. And then once we get to the edge again, you'll see the blue map. That is the repeating map. It's when you're outside of the red map and into the blue map here, the blue map repeats forever. The red map is unique and lives in the center of all the blue maps. All right, so that's the player one. Okay, we need to get our base scaling factor defined somewhere. So let's look at our startup resource here. We're going to say export float. Float. We're going to say it is 3F here. Then inside of our entity mesh renderer, instead of setting it to a forced 6 here, we are instead going to say services startup resource dot scaling factor. Well, that's not right. That's why. 32. Now, what this lets us do is we can still have different sized things. So I can have bigger or smaller objects as I would like. We do want to avoid getting too much bigger than 32 by 32. Without working with the screen resolution. The resolution of the game is 1080p. Widescreen 1080p, you know. Well, not widescreen. 1920 by 1080. And what we want to do is decide on the scale of the sprites accordingly. Then, based on that, we say, okay, well, we know how big the screen is in pixels in that case. Then we need to decide, given the base size of a sprite, what is the expected scale of any individual sprite? Like, which is the dominant sprite, I should say. So the player sprite is the one that we're basing all of this off of. They're 32 by 32. Any sprite other than that then needs to be scaled according to that sprite. So I think having something that says this is the assumed core size of a sprite. This is the base size. If something is bigger, then its scaling factor is adjusted accordingly. You know, does it need to be shrunk? Does it need to be blown up further? The reason that we do need to change the scaling is that when the shader runs, it is squished. So we're going to de-squish it. I don't know how that will work if we have things that are much, much larger. We'll have to do some tests with that. Let's do an interim save here. We're making progress. Interim save. So this is the only place that we have to deal, more or less have to deal with the scaling factor, because this is where everything is rendered. Constant vector 2. Fine. We'll also need to account for some of this, but for the time being, it's going to be a bit trickier. Like, saying that it's 32 by 32 We still need to figure out how to get the scaling to play nice when it is different sizes, but I think we could still do that. We just need... Right now, though, sprites are set up to be squares. I don't have a big reason to make them not squares. To width. That's width, and then this is height. Okay. Yeah. It's when they're not tethered together, they behave independently. I still need to set it up so that you can move the weapons around. That is a relevant operator now. Okay, we have that. Let's... It's okay that it does it that way, but we don't need to keep references to it. Let's go fix them. That way we don't have the risk that there is some sort of change and it's talking to the wrong thing. Okay. Let's do another intermediate there. Reference to surfaces. Which still lets all of this work. Okay. Yeah, there's more of this that I'd like to change, and boy, I would really like to do this differently. But that is what it is at the moment. Well, in our collision handling, I kind of want to look at that real quick. Buffer. Should be able to... you can't see much of Molly there. This is a compute shader that handles checking where the collisions are. I think we could use this to handle the textures differently, because I'm predetermining. So there are shader entities. Sorry, this is what a shader entity looks like. This is the structure for it. This is what the rules look like. And then the entity buffer is an array of shader entities. So I don't have that predefined. It is a buffer. And I think I may be able to do it this way because it's a compute shader. that I'm not setting up the buffers in that fashion, but a look at how I'm actually doing that. I'm curious now. We'll get to more sprites shortly. Do some more icon work. It is in our collision handling. Close our other tabs. So this is us defining where to find our collision check thing here. Arrays, we have byte arrays for it. Setting up the rules data, and then we set up the buffer for it. We say this is how many bytes are in it, and we're passing that in. Create storage buffers. So I'm not setting up the buffers in the same way when we're rendering, though. We're setting shader parameters in this. I wonder if we could set up buffers. It would be really handy if we could. Entities. Shader file. Rendering server done. Wonder if there's a way for us to get rendering information from it. So what I don't really need to change this right now though. But these uniforms are the part that bugs me, because it is information that I would like to get elsewhere. Right now, I have to predefine this, and then I have to load it in to say, there are up to 100 textures. I will create a size 100 array of textures, and we will use that. Then with this is we have local variables, and we load those in via the custom here. You get a color value. So you get what amounts to a 4-dimensional vector to pass in custom information. There are other things that we should be able to do. But yeah, we do want to change this. Is we don't need entity ID. Instead, what we want to be able to do is just say which texture, which animation row to use, when did this animation start, and should we loop the animation or not. This is where things like how long the animations are would come into play. Being able to say, this particular animation has 6 frames would be neat. All right, let's get some new sprites in general. So we have the 32-bit player. Let's keep that in place. Bullets. So we have a yarn ball. Let's get the red dot in there. So we will need to add a little bit of red into our sprite here. Let's see, what did we change? All right, we changed the red value a little bit. Okay. So we have a bright red. We can do darker reds for this purpose as well. But we might do some less hard reds. We might make it a little bit transparent around the edges. For the time being, let's just get red with the dark outline in place here. Out. So dead center is here. This is where we want to base everything. We can do... I kind of want it to be a little taller than it ultimately is. We could also make it just noticeably smaller. It does not have to be 16 by 16. But let's start with that as a concept here. don't know that we'll necessarily do the outline, but idle and active are going to be largely the same. I think with the difference being with active, we're going to do a little bit of a trail off the edge here. This will give us some room. Okay, we're gonna have some kind of rays around it. So we have 6 frames. We need to make sure that we come back to neutral after that. So we effectively have 4 that we can play with. I kind of like the idea that it would be emitting upwards, you know? Because one of the gimmicks on this is it's kind of a targeting beam. Kind of a targeting beam. Let's extend it out again. Kind of like that it would be wider. Like that. And then we have five different positions for our sparks here. We could just have it sweep across. So a dead moment and then all the way across. Let's see. So here to here is pretty quick. Everything else is moving one at a time. So if we start there and we end, moves one. This one should be okay. How will we make that look good? Well, we have a lot more room to play with. Like, I think this should be about the peak of it. So we're just going to draw a line across here. Okay. We could add a little bit of a tail to it here. There's a little bit of a lingering distortion at this point. It's like we could have a bit of trail here. We'll start with that. So this is idle. We're probably not going to see this one a lot. Now this will be the same thing, but with a little bit of a trail of motion here. So neutral. So I think that's as far out as we want to get. So we're going to shift, comes back in. Out. Spark. Out further. Just the spark. Shifting to the other one. Out further. Just the spark. Then we're going to adjust. We're going to slightly shift. So we're going to kind of push the beams back, or the little glow off of the beams back a bit. Molly is being a little kissy right now, licking my mouse hand. Very sweet, but she is also very slobbery. Like, it's not direct drool, but there's a real spray when she licks. Little sweetheart, though. Do a quick cat check here. We can see 3 of them. You can see a little bit of Molly. Sammy on the bed, and Ember across from the keyboard. Sherbet is at the little window tree. Zoom in a little bit. Molly is the most varied in where she'll hang out. She will hang out in that spot too. So now it is only Sherbet and Molly that will go into that little tree. Ember doesn't like it. Mason and Sky are kind of too big. Sammy also doesn't like it. At least they're not interested in using the little house. Okay, so we have bullet red dot here. We're going to export that. All right, we have a new texture. We have the red dot. So let's get textures. So not. False. It does not rotate to face. Then we'll need to get that icon in there for it too. Dot. So we then need to go into our icons. I'm gonna have to splinter these off. I need to come up with a pattern for laying the icon on top of the square here. We'll deal with that later, though. Another thing for the pile, another thing for the pile. And we're going to take you... as dot. Okay. So we have the texture. We need a bullet here. So that texture, we need a base behavior as well. Dot. So it's going to be these parts, for the most part, that change for this purpose. So say movement to cursor. That's what we want to use. So that's the red dot's base behavior. So group red dot. Is a bullet. It looks like the red dot that we just made. And it uses the red dot behavior set. It's about 10 seconds that a bullet will last. It does 1 health damage to enemies that it collides with. I'm sorry. It has 1 hit point. That means it can collide with one thing, because when it collides with something, it does 1 damage to itself, does 1 damage to what it collided with. This is going to change here. The red dot is meant to be a payload. I'm sorry, is meant to carry a payload. For the time being, we're going to leave this as is, but this is where we will change it. As in, you don't bother with the red dot unless you have something for it to fire. We will have move to cursor have a turn radius. We'll have to add that in. But, okay, so we now have the bullet. We now need a spawner item for it. Bullet defines the behavior. No modified behaviors. It will fire once a second and spawn 1 at a time. Starts on the player. Okay. Now we make an item for that. Again, we're deriving it from the yarn ball. Nice starting point. Dot. this is redundant. We'll have to check and see how we're actually referencing that, but we don't reference that entity. We care about the spawner, but actually, getting the entity is useful to us later because we don't always create a spawner from it. We'll see how this plays out. I feel like this distinction between these two can lead to some discrepancies. All right, so we have this now. Now we are going to go in and we're going to go into our player loadout. So we are going to add another one here. Red dot. Yeah, 1, and we're going to pull you down to 3. And now we attempt to run it. Red dot has a bunch of behaviors filling in on it. Put an extra track in there. We'll put the zigzag on that. Well, I'm sorry, we'll put rotate on that one. Put a split into 3 on you there. So you can see the red dots homing in on wherever the cursor is. Which lets us do things now, like we could have this be a periodic payload, and then this one be on impact. Oh, no. This should be... Oh. Wait. No, this should be getting consumed. Yeah, the yarn ball isn't behaving correctly here. None of them are. This one should be consuming this one. Yarn balls are emitted on impact, but the red dots are... Should probably change the flow of the little kind of flames off of the top of the red dot in the reverse direction, but it'll do for now. All right, let's check our data files here. All right, now we need to look at our inventory weapon construction here. Figure out once again where I built this. Oh, it's at a 5th row. There we go. Gives us some space. back to front. So let's run this, and we're going to break on that once we're... So this one's on impact. Now we're going to go to here, and we're going to make this change. Okay, so this is row 3, I is equal to 2. It's the first one that we've had that does have an inventory item entity here. And it is the red dot. So this one's going to be built out. Okay, we come back around, and now we're the yarn ball. Now this should consume the subsequent one in the process of this. Where we convert weapon to entity here. The number is 2. All right, spawner item count is off. It's interesting. Hey, bud. Yeah, he's come to visit. So he gets chin scratches. Out of this, out of that, that. It's 1. Oh, okay. All right. We still have that logic wrong. So our problem here is that spawner items, when I've inserted one, the difficulty is the index in this is not what we're talking about. So this is going to call into convert weapon to entity. It's going to say, like, I'm getting the yarn ball, and that one has an index of 1. The red dot has an index of 2. But at the time that I've inserted it, spawner items isn't like where it should be. So we're inserting this at the beginning. So yarn ball is now at position 0 and red dot is at position 1. We want the red dot. We want the next one. So how do we get that dynamically? Because we want to be able to define it at that moment. We should be able to do that here. All right, what if we do 0 here? Each of them firing independently. Mouse goes to impact trigger. Yarn ball goes away. Yarn ball goes to divergence here. We just have mouse. Okay, mouse hits, yarn ball emitted. Yarn ball periodically emits red dot. Not necessarily how I wanted to have that work, but it is how it is. Then red dot spirals out from cursor. It won't necessarily like that much. Yarn ball moves in a wave, and the mouse spirals. So again, the intent of the red dot is that it would always impact payload. So that's its base behavior. No other impact logic would really play nice with it. It could also have a delay or something like that, but it will be some sort of by default, it triggers another weapon. So by itself, it can do some harm. But if you wait long enough, or if it hits something or something like that, it will emit the next projectile. That will be its base behavior. Okay. So that added red dot. Sip a beverage here. All right, how we want to do next? Let's actually wire that in. Let's get some more behavior here. We won't have this one have an item yet, but we do want the behavior. Game entity multiplier timed weapon entity. Okay, so we need a behavior for this so that we can graft it into the red dot. Behavior. Entity. Timed weapon entity is very like periodic. Okay, and what's our variable timer? And it wants to fire, let's say, after 5 seconds. So no matter what, after 5 seconds, it will try to add new entity. But it needs an entity for that to happen. If it doesn't have an entity, it will continue in its normal path. I kind of want to have it be that even if there isn't an entity, it will fire. Yeah. So, if there's an entity, then we're going to do this part. I'm sorry, we're going to do these bits and this bit. If there's an entity, we are going to make a new one, put that in there, and we are going to add it here. But no matter what, this entity goes away at that moment. Yeah. I kind of like this. If it's a timer, it will get rid of it and emit the next one, even if that next one's not there. In the same vein is the collision one, I think I will make it so that even if there isn't an entity, this one's going away when it collides. Because the payload is, upon hit, fire the next thing. If there's no next thing, it is fire nothing, but you still go away as a result. Okay. So then, in the red dot, we're going to add multiplier timed weapon entity. And it does not do harm or harm self. It does not have health. And in the player, we are going to do red dot before yarn ball. So we can't reorder them right now. We're going to put them in a fixed order. We can change that in a moment here. So there's no yarn ball, but after about 5 seconds, each one of these should pop and turn into a yarn ball, but they are not. Okay. Could have broken at that point anyway. Timer is nothing. Is this copy not happening? Because it is coming through, but we should be getting a copy. Oh, that's why. Because it's not a periodic, it's a timed. It was saying, if the thing you're trying to copy is a periodic, try to cast it to a timed. Well, the copy for this one is never going to come through as a timed. Okay, so let's try that again. Oop. Yep. At 5 seconds, the red dot turns into a yarn ball. Force this behavior here, here. So the red dot does not hurt at all when it touches things. Can we make it do that? Yes, we could. And we could also have it be on impact. It does something, and that would override the timer. Yeah, let's verify. Yep, it will either expire or it will go off when it hits. So we're going to remove the spiral. All right. Okay, that puts red dot in place. Let's get that code change fixed here. So the problem we were having with the emitters was we have to go bottom to top, but no matter what, the last one to be created is weapon 1. We just created weapon 0 because we inserted it at 0. So the prior weapon in this process will be weapon 1. All right. Next, we've got to get an explosion in place. This is kind of fiddly. An explosion can hit any number of things at once. It does not care about... Like, it's not stopping at one collision. It wants to hit everything. So if we look at the existing... So... Collision change target health. It goes into a wait state when this happens. We're going to add a flag that is like a collision limit. If it is 1, then after 1 collision, it goes into the wait state. That is equal to 1. Limit equal to health is equal to that. Yes, hello. Oof. Limit. There we go. On ignore. Zero. I think we'll have to change that, but it's greater than or equal to collision limit. Waiting is equal to true, and collision count is equal to 0. It's not time passed, it's end step. We don't need to wait a whole frame. It's by adding end step we've gotten to the end of the chain. Next frame you can do it again. Okay. if collision limit is greater than 0 and we've exceeded it. If collision limit is equal to 0, then we will never enter the wait state. We will collide as many times as we need to. We will need to figure out how to make the explosion live exactly long enough. But for the time being, it's going to be kind of weird. So we're going to go into our behaviors. We're going to go into our collisions. So we have collision help. We have collision harm. Oh, excuse me. Collision harm 1. It's going to be mass harm 1. And mass harm 1 is for explosion purposes. And it will be collision limit. That is 0. All right, so now we need a new sprite. This is technically a bullet. We're just going to start by calling it explosion. It will be something different. We're going to make this 64 by 64, so it is 128. Yes. So this expanded it out. Then we can do preferences here. Grid is do 16 by 16. Okay, so its default state, its animation will end with nothing. Then we want we are going to try to fill it by this point, which means this should be about the midpoint. Looking at about there. That. Yep. So technically it caps out a little early, but at this point it will already be dissipating, but it will be at its largest state. So okay. We will start with we're just going to have an expanding circle. Circle-ish. Circle-ish. Take you, paste you in the middle. Same general thing. Two. That. Lined up. At this point, I kind of want it to be coming apart more. But again, for the time being, hello, Sky, I acknowledge you. I do. I do. Yes. that. There needs to be some sort of, I don't know how to fully put it, like diffusion going on with this. So now instead of 2, we're going to do 3 rows. Get the full look. 2, 4. So same thing for the next one. Might reverse the colors on this. Canonically, if it were to be an explosion, it would start with the bright color there. Will we actually use these colors initially? I don't know. We might have again, a canonically less terrifying color set. These particular colors here would be very bad. Whereas the outer colors would be kind of neutral. Not good. Placeholder graphics, placeholder graphics. So again. All right, now we're just going to start tearing it out into pieces. So hello, tomatoes. I agree with the sentiment of your name. Tomatoes are not to be trusted. Let's see here. Quite much. Guy, what seems to be the problem, huh? What? This guy is chirping at me. Still got to keep an eye on his eyes, especially his right eye. Yeah, looks about right. This still leaves enough in the corners to look pretty good. And once we have this wrangled fully, I can just flip it and mirror it over top of the bottom, save ourselves some time. Sir, what's the problem? The microphone doesn't pick it up, but I am being extensively chirped at. Isn't that right? Okay, so we can take this part, get rid of that. That part. Edit, flip vertical. Just so. Suppose I should have done this part first. Part of the goal will also be to not use this particular dark purple anywhere in the game other than on things that you can interact with in some fashion. Enemies, bullets, the player. The dark purple is an outline to objects that are things in the world, you know? Alright, let's do that again. Vertical. And excess. going to do similar again. Effectively, we're going to split it up further. Do not do the bottom side of it. We will handle that. Like that. Precisely what I want here, but I mean, this whole portion isn't precisely what I want. Now we'll do the black lines. This kind of thing is something that would be useful to have particle emitters for. this. Actually, first we this portion. Paste horizontal, so paste vertical, add a little bit of precursor. Oh, better. Cross, tick, cross, tick, crossed. Take that. Paste, flip vertical. Not the end product once more, but it'll do. No, we're not going to over-focus there. As bullet explosion here, and we are now going to take bullet yarn ball, copy it, paste it, bullet. All right, that is 64 by 64. Does not rotate to face. We could actually do that to create some variety. I will leave it. It's not going to operate in that fashion. Okay, there's our texture. Now we need a bullet for it. Moment. We'll need you in a moment. Don't you. We need a base behavior group. You do. will need a different lifespan for it. It needs to only live for a single frame. We're going to take a break here. I've got to make sure that he has enough food to stop bothering me. And, we haven't had a break yet during the stream, so we're doing that now. Oh, okay. Yeah. navigate the kitty cat gauntlet here. Okay. All right. So we need another behavior in here. Call this explosion span. Let's see, 0.01. This may not work. We're gonna play with this a little bit. Okay, that's base explosion. Mass harm is set up. We need a spawner and an item. Time, second. Explosion bullet. Now we need a spawner. Oh, we just did that. We now need an item. We'll also need a texture for. Get that icon. Data textures icon. Then hello, Ember. Hello. Yeah, if I remove the requirement of having the frame as part of the icon file, I can just have the icons. But we'll deal with that once we're ready to switch to the 32x ones. Okay. Icon. Explosion. Now we need to go into layer again. Oh, that's an icon. That is a texture. Layers, Nyanite. Typing impeded. Cat on right shoulder. All right, let's make sure our explosion item is set up right. Explosion. Needs to be protected then. Let's look at a timer lifespan here. Is a double. Liking that. Closely. 4 on 27. Seven on that. You should be correctly escaped. Pattern that I have to follow for this, I'm not understanding. All right, so it errors when it is a actual double. Here. Look up. Look up. a leading 0, then it doesn't like that. But if it doesn't have a leading 0, base explosion lifespan is not found at that point. Which means it's not actually managing to retrieve it. Sure, that's how I spelled it in the file. Huh? Not finding it in the group, but it's being loaded in timers. Other things can use timer. And a lifespan of just 10 does just fine. That's it. That's the only difference. Is what that number is. So if I change it to 1, like some sort of like terminating character that's wrong here. What is wrong with this particular one that it's not getting loaded? Let's go into the catalog. Services. Catalog. Base catalog. Set them up. Timer behavior path. Timer base explosion lifespan. Base bullet lifespan. Is a thing. Back around, we have a file path. Invalid start of a value. Okay, starting with a period doesn't work. No. Okay. It did that. Catalogable is a lifespan 0.01. Welcome back, Tess. We are trying to find an error with a JSON parse here. Okay, it's the array. It's the array. It's not this, it's in the group. Right there. Barking up the wrong tree. All right, let's add a row. New sprites. Yep, I've got the new player sprite in place, Tess. And we've got them rescaling. So we can see we've got our new little animation. We've got a different idle. We've got our red dots. This is... Okay. We need... We're going to give it a full second. Still not showing up. That should be appearing as soon as that happens. And it's spawning right on top of it. All right, let's give it the same lifespan for now. Explosions are not appearing. Let's change the order. See if it will appear, period. It is not. All right, let's look back over our settings. Oh. Get that in place. Okay, if it still doesn't appear, then it's probably a rendering issue. Oh, there it is. Okay. Now let's get... Okay, you can very briefly see it. Not quite right yet, but... let's look at our explosion here again. Okay, we have a blank frame. We need logic for whether it loops or not to be in the shader. We don't currently have that. So I need a lifespan that is effectively that it exists for long enough to render. Like, I wanted to loop the animation once, but that it only is viable for long enough to be visible. So we need to get looping in it. So do we have looping already set up? I know, Ember, I know. Well, if you know, do it right. All right, do we have anywhere where we've set up whether a texture should loop or not? I don't think we have. Let's go to texture wrapper. Set is equal to true by default. Then in our shader here, our entity mesh renderer, texture wrapper loop animation. One. Zero and if true. Generally, if true is better than if not. I'm sorry, if value is better than if not value, just for legibility. No, I know. Yeah, I know. She sits, and eventually she'll start to stand up if I don't give her sufficient backstrokes. If she stands up, from then on, one of her hind legs is going to position its claws right on my collarbone, which is not comfy. All right. So now we are passing in the loop value. All right, flat. Ooh. Loop animation. Okay. Do this. Right. That. Whoa. Just do as an int, just for consistency. Semicolon. Greater than 6 and frame modulo 6. Else. All right, let's try to run with that. By default, nothing should have changed. Okay, everything's looping. That's great. So then in explosion here, we are going to say animation. False. Okay. What did I call it? I called it loop animation. Oh. No semicolons in JSON. Okay. Gonna oh. No, no, no. No, it should be stopping there. Loop animation is 1, then we're going to mod it. Otherwise, we're going to force it to be frame 5. Should get that at least once. But we didn't. Okay. Boolean, loop animation. Bullet explosion has loop animation to false. Double check texture wrapper because we're not copying it. All right, let's go back into that shader. Okay. If loop animation is equal to 1, then frame is equal to this mod 6. Otherwise, we can make this logic better, but I'm sorry, we can make it cleaner. No matter what, frame starts as this. Okay, now it's not playing it at all. That will always be. This will always be too big. Okay, now we need time sense animation started. Okay. So time is when the application started. So we need to get that value whenever we set an animation. Target. Entity animation changed is where we're doing that, where we're setting this. We should keep the entity's animation present. And whenever we do this, if the animation is different, then we are going to send a change here. I may want to make it so that if you set this manually, then it will trigger the event. But for the time being, we'll just roll with this. We are going to have a animation does not equal animation. All right, so now we're looking for the entity animation change, which should be in the entity mesh. Started is equal to what? Look up, we need when the thing started. Microseconds and milliseconds. Okay, which is it? Oh, we don't need to worry about that. Okay. Okay, we are going to be getting ticks in milliseconds here. So get ticks in milliseconds. So this is thousandths of a second. So divided by 1,000. This is the seconds that have passed since the animation started. This is how long the animation has been running. So we are going to pass that. We are going to shuffle some stuff around in our shader now. It's not the ID that we care about. We do not care about that ID. Well, currently we do. We don't want to. So we have the index of the texture, which is the R of it. RGBA. So we still have the texture index. We have which animation we're using. So that should be G. And then time since started. already afloat, we're being explicit about it. And we're going to take animation runtime here. Right, then we need to go in to the actual thing here. Okay, so it's the texture index, which animation we're using, the entity mesh animation runtime. Does it explode? Oh, okay. We are not getting any sort of animation runtime in here. So let's zero. "11 seconds since the engine started." Oh, no. It's not when we update it. It's every tick we need to update that. So it is when the animation started. When the animation changes, we set this to the current one. We still want it to be the runtime, though, in the shader. Yep. This is how long it's been running. So then if we go back to our entity mesh renderer, right here, so here's the start time. Go.time.get milliseconds by 1000. Minus that. Nope. Why is that acting static? Texture animation runtime loop. Stome. Animation. Okay, then in our entity mesh, we are updating this, but what we'll do is when we create the entity mesh, we are going to start time is equal to that. Okay, so now we should be red is the texture index, green is the animation, blue is the runtime in seconds. Look at what it is each time. Why is that not getting set? Okay, it is updating. Huh. The shader again. So something we're missing in here. After roughly 500 million years. Yeah, it's... There's also this just terrible gravitation towards trying to use... Like, they really try to torture a hot commodity into those mashup kind of statements. And it tends to force it to be wrong. Like, Stardew Valley is generally used as a shorthand for farming life sim. Like, a very particular sort of farming life sim. If you went back a little bit, it would be, oh, it's like Harvest Moon or something like that. You know, there are visual novel style dating candidates and similar that you must woo, and then on a daily basis you must plant seeds and harvest them kind of stuff. And then you take something, it's like, okay, Skyrim. Well, that implies a lot of stuff. That might as well be like saying Souls-like. So, you know, oh, there's generally a first-person perspective. There's an emphasis on combat and a real kind of very open-world mentality. So, it would be better to choose one that you look at it and say, it's like this game the most. But, you know, it's like Skyrim, but with farming. Like, okay. But, like Skyrim is already a big wide open bucket, and then taking like Stardew Valley, which is a big wide open bucket, and taking the two of them and hoping that that's meaningful is a reach. Animation has become 1. Animation start time is 3. Okay, all of this makes sense. I am getting seconds since it started. I would understand the Skyrim one more than the Zelda one. Because there are plenty of the farming sim games that have started to like branch into, you know, questy combat mechanics, you know? Right. Even Stardew Valley has started down that road with the little cavern, and you know you can make and get weapons and fight monsters and such in order to get the stuffs. With the Zelda one, it's like, yes, you can fight, but there is the added aspect of there is a particular kind of other playstyle. Right, Tass, right. I really think that we're already starting to get AI slop for a lot of these web articles about gaming in particular. I know we're getting AI slop for other things, but gaming definitely, and there's definitely a vibe of, you know, create an article about this, and since there was already a propensity to say, hey, it's a game like this, then they can only write, it's a game like these things. It's a game that's a mashup of. It just, it tells us nothing. Or merely leaves us confused. Okay, so the animation is not cycling. We are getting a floating point value in. Right here. So we're getting the next value. And we're subtracting the existing one from it. So we come in here. And almost immediately, so our animation start time in the entity mesh is 2. And as far as this is concerned, we're going to get a distorted value. That should be about 15. 15 and a half, you know. So we pass it in as the blue value. And then over here, we come in, and out of the blue value, we are getting the animation runtime. This is in seconds. The times 6 doesn't help me. That should result in it since it's an int, it's always that's exceedingly choppy. Godot, what do you say? Where is our error that's causing that choppiness? So our frames per second is terrible during that. Did I have two of them running at once? Oh, no, it's fine. Animating super slowly. So it should be divided by 6, shouldn't it? It's in 1/6 of a second. Also wrong. What? Unlock. Should be divided by. So we get a number of seconds coming out of this, and we're saying we should animate 6 times a second. So I can't do modulo 6 in that case, because it will just come back as 0 if I multiply by 6. So we want 1/6 of a second. It should be divided by 6. Right? We should be able to get fractions in here. So times 6 should work. Ah, tricky. Tricky. What am I missing here? So again, this is seconds since we started. That's a long. All right, let's force this to a float. There we go. Okay, then we're going to change you to be that. Okay, now on impact. Ball has definitely hit, but it's bouncing because the bounce is happening first. There it goes. All right, let's remove the other weapons for testing purposes here. We are going to only leave in the mouse and the explosion so that we can see it clearly. So mouse and explosion. Say on impact, set off the explosion. We need to speed up the blob spawn to see if this is actually doing what we want it to do. Spawn 5 of them at once. We're definitely not getting everything working correctly. Okay, they are removing some of the blobs. Part of the trick is that explosion is living way longer than it's supposed to. So it can hit extra things. And we're also seeing the animation is not lasting long enough. Or the animation is not starting when it should. If oh. Need to go to when that changes in the entity mesh. What? There we go. Is when we were setting the other one, we weren't making it a we weren't properly setting it up. And we still aren't. When we are moving, our animations aren't being updated properly. Walking animation is the animations are constantly they must constantly be changing if this is getting reset. Blue. Those numbers are coming through. It's ultimately it's those decimal values that are going to matter there. Ever an entity. Hey there, Okaneki. Good to see you again. We update our animation. Ah, okay. We're not changing animation. Doing okay. Kitties are doing okay. Let's give you a camera check here. Let's see how many we can spot. We have... Who is not visible? Sherbet is not visible. Everybody else is visible. Got Sky, Ember, Sammy, Mason. I presume that's Mason in the upper left of the bed, and Molly. Alright, that should fix here. Yep, there we go. Explosion is not visible, though. I don't know why it wasn't visible here. Oh, now it's working. We need to make sure that the explosion is fully active for an entire physics frame. And that the hitbox is accurate. The hitbox currently should be 64 in size, but maybe there's something not getting through there. We've got a whole lot of new stuff in the game since I think you last saw Okaneki. I'm not sure. Maybe you've been keeping up on it. Lots have been happening. Lots have been happening. Getting radius. Buffers. Should have an on. There we go. On entity added. We add our shader entities. Radius should be 32 in this case. We have the radius being passed in. Let's further limit what we've got active. Let's remove wind up mouse from the equation so we only have the explosion firing. mean, it is hitting everything around it. We are going to get extra hits because the explosion is technically lingering. Which, if we make it linger for a small enough period of time, it's okay. But we need it to linger only long enough to hit everything that's present. Okay. It will only register a hit with a single target, and it only lasts. I'm sorry. Given that every entity can only take one hit, then right now, then the explosion won't hit them multiple times. If right now the explosion doesn't have anything in it that will prevent collisions with other entities. With an entity in a subsequent frame. What we want to have happen is that the explosion will only do its collision checks in a given frame. That is, once the end step has happened, it stops doing damage. We can do that, but we need to make a distinct type of harm for that. On impact when they're that close. And do that as well. We are periodically losing a portion of the explosion. And I think some of that is because of a potential desync between when we update the frames. Because it's 1 second. Yeah, we're not getting the entirety of the explosion animation. I'm not seeing the breakdown in the animations for the entities. But I'm also seeing that there's a definite sync up in their animations. Like, all of the blobs are moving in lockstep. I mean, they are emitting with regularity. So they're going to land on the same frame. We could offset it ever so slightly with the spawner. Like a small randomizing factor, but Unsure. Unsure. Let's look at entity mesh. Yarn ball is actually not the best one to test this with because its bounce will reduce the number of explosions that we see. We are still occasionally seeing very brief-lived explosions. Most of them are coming through correctly, but every now and then we have one that hardly gets anything other than the last 2 frames of its animation. They're mostly correct for the explosions. It's mostly correct. It's that I'm not seeing hitches in the others. I'm seeing too much sync up between them, which bothers me. But that is, again, already something that is... like, we know that's a possibility. When it comes into existence, we get the current moment. Float. There we go. I don't know that the explosions are firing correctly as far as doing damage, but, I mean, I got the animation down. We know what the problem with the animations has been. And that's getting the current milliseconds in there. So I should make that like a utility function is, get seconds since start kind of thing. So I don't have to keep doing that, float of get milliseconds divided by 1000. So we'll make a static utilities object to have methods like that, where we're just always going to call time.getMilliseconds. So how will I impart a little bit of variation here? All right, let's do impact. Right. It's entirely because everything is coming into existence on like second marks. Since every blob is showing up at like 1 second at a time, instead we do 0.5 and do 3 of them. So the blobs should have a little bit of variation in their movement. Yeah. It's if they spawn on in 1 second intervals, then everything spawns with the same animation. We can fix that by making it so that it's not 6 that we're looking for. Or I'm sorry, that it's not per second that we're looking for. So if we look at our shader, part of it is this cleanness here, where we're saying there are 6 frames per second. We could make this a messy number, but it needs to be some sort of integer, though. We could also add a plus or minus a millisecond kind of thing. Which would not influence it enough. I don't know. Worst problems to have. Worst problems to have for now. It's getting that offset in there, though, is where we'll be working on it. All right, I'm starting to lose focus here. Let me see. Okay, what are we doing? We're gonna take a quick break and see if I can get my train of thought back on track here. So there's a couple of things that we need to make the explosions work better. One is a single frame lifespan, as far as active lifespan for collisions. It's okay for it to live a full second, but we are going to have a cease to be collidable scenario. We're going to change its type to 0. Immediately. Like after so many ticks kind of thing. So it will continue to live for a full lifespan, but it will cease to be a thing after that. Because we still want it to collide. This needs to be in the end step. That it would do the calculation. So there's two stages. There is still time passed, and there is still like its lifespan. How far do we want to go here? So if lifespan ended, we handle the message. Like any subsequent hits on handle message, it will just handle the message. Tempted to remove that. Let's get a quick interim here, though. That's for testing. Should have done more interim saves here. Okay. So it's lifespan that we want to have here. It needs to live for a full second to play out the entire animation. But there is a second, there is a initial death that happens. Because it can still move after that period. Like, behavior could still have it move around during that second, which isn't ideal. But that's why lifespan happens first, and that's why this is. If their lifespan happens first. Okay. So what we're going to do is we're going to convert it to a category 0. We look at entities here. So when we get the entity category, it becomes a not set at 0. So let's check our collision manager here. Shader collision manager. Entity collision mask. There should be a function in entity for collision mask. Okay, it will be 0. It itself does not collide with anything in that scenario. All right. So its type will be set to 0. So entity category not set. All right. All right, we're going to call our own first, but before we return, we are going to call the parent here. There are effectively two lifespans. There's the first one, which still accounts for, like, we don't eat the message for this new one. There's 2 stages. There is the entity being removed because its lifespan is over. Its full lifespan is over. There is a sub lifespan that is going to exist that is, as soon as this lifespan is crossed, we are going to, so that's lifespan ended. This is the second one. We are going to eat any subsequent message if lifespan has ended. So we're going to have a sub lifespan. I mean, really, it's a secondary lifespan. It's the sub lifespan says, it's the first lifespan is when do we disable the thing? The second lifespan is do I persist for longer than the base lifespan? So the initial lifespan is it will disable it. Then we've got a persist time. Here we go. Okay. So as soon as lifespan has ended, we will consume the message. Do this here. Okay, so lifespan plus persist time is where we will completely remove the entity. If time passed is greater than lifespan, this is when we are going to set the entity's category to nothing. So this is going to make it cease to collide. This is going to make it that the entity has ceased to be. We don't need to do this over and over, but it should not hurt to do it over and over. This is any lifespan ended. Okay. Let's verify we didn't break it here. Okay, we're still getting things going away. Okay, so now in the timer base explosion lifespan, its lifespan is 0, but its persist time is 1. Okay. Oh. Immediately, what's wrong? We need to copy that over when we copy it. All right, so explosions only live for a single frame. They look like they persist for a whole second for the animation. Okay, we are not getting the hits, though. Oh, it's immediately being set to that. Okay. Okay. Okay, it's only during the end step that we should be doing this. End step message. There's still more adjustment I need to make to this. But we can see they are being wiped out. Can be a bit of a delay. We'll need to work on that. Yeah, Working, though. Okay. So this is a time passed. It goes through and says, okay, if we've already... All right, again. This... else we're going to update time passed. But effectively, if lifespan is ended, we just say consume the message if it's time passed. If we get to an end step, so it should be time passed and then later the end step happens, then we're going to check and see which of these is true. Or if both of them are true. We let them go in sequence. We do not consume the end step. Everything gets an end step. All right. So this makes them linger, but it also means that their time passed will be consumed, assuming you properly put lifespan first in their behaviors. Put lifespan later, you're already going to get weird behavior. On impact. The iron balls bounce, so they have to hit twice before it'll actually do the on impact. There are multiple explosions going off at once. We are getting hitbox anomalies going on. Run that again and just take a closer look. Another thing I need for the... Okay, yeah, we're still getting collisions on the explosions that are... The explosions should be gone, but we're seeing like rolling deaths before the things go away. Well, after they have gone. Like right here, some of the slimes, yeah, we're getting slime removals like well out of range. But by changing its category, its masks should get updated. But perhaps... I mean, they shouldn't be lasting that much extra time. By default, persist time is 0. Bullets should live for 10. It seems like the explosions are lingering longer than they should. Which is weird because that's the opposite of what we set out to do. Is when the initial lifespan ends, we set its category to not set. But we're only updating its collision mask initially, when we initially load it. We'll need to raise an event to change. We would need to change an event, raise an event to change its collision type. We would need an event on the entity when that type changes, when the category changes, in order to, like, we could have an update category that when you change it after it's created, that we call an event and we would indicate that. Because right now, even if... No, it's 1 second, though. It shouldn't be living that long. Like, we shouldn't be getting phantoms here, I guess is what I'm getting at. Let's go into the player. We're going to remove Yarn Ball. We just have the explosion. The blob's lifespan that's coming into play. Spawner, behavior groups, base enemy. Enemies do not have a lifespan. They should not be going away in that circumstance. Yeah, there's a lingering kill zone up here. Ah, I see it. Okay. As soon as lifespan has ended, we stop updating time passed. We still need to update time passed. They were never actually going away. All right. Enemy. Let's get that base enemy one. In theory, we should be seeing the blobs shoved a little bit. But I think knockback might be broken. Yeah, I think knockback is broken based on some prior logic here. So if we look for proposed movement. So at the start of a time passed, we're going to zero out proposed movement. So it's in the physics update subsequent to. So it is after we would do a time passed. We're going to do the physics update where we update the entity's position. And then we're going to call into the physics logic. This is where I think we need to update proposed movement to nothing, but let's see. Let's see. We update the animation, which we need to understand proposed movement to do that. And zero out the vector. Then in the end step, so we pass it to everything else. Message. Void date position. Update the animation before we update the position. When we update the position, that's when we zero out the vector here. Then if it's an end step message, we are going to try to update position again. And that is so if we got pushed or something like that as part of collisions, this is where we're going to force that again. Again, we might not see this with the blobs, but if the blobs do get to us, we would see it. let's add the red dot item to the player again. Item red dot. Okay, only the red dots go out, and we will have they expire, the explosions go off. Yep, and you get shoved when you're hit. Alright, we fixed knockback. If we also... we could change it so that enemy health is by default more than 1, but I feel like that's a good starting point for health. Okay. Something here. Okay, I think we're going to wrap up there, all things considered. We've done a lot today. So we've got 2 additional items into play, the explosion and the red dot. Red dot for cursor tracking and timer-based trigger. Red dot is intrinsically a trigger. That's all it does. It has no impact damage or anything like that. It triggers the next weapon. And the next thing that I do want to do is get it to where you can move the weapons around. That's going to make a difference as far as making things like the red dot a viable choice. Red dot also needs to be a can't show up unless there are other weapons thing. We got things changed over so that we have a default of a 32 size as far as the entities on screen. Might still zoom in, zoom out, or something like that. Just back on that. What else? Got knockback working. We've covered a lot of ground today. I hope everybody had a good time watching with us. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment, all those good things. It helps the channel grow and will help you see things like this in the future. With that said, I hope the rest of your day is good, and I'll see you next time.